Team test is Thursday, so it is tomorrow. Okay. Val was here yesterday. She saw it. Val, what do you think?
Yeah.
So, yeah. It's doable. She also saw the test. Right? She came in for tutoring. She was the only one that came in for tutoring. None of you guys came in. I've been hosting tutoring after schools. Mm-hmm. Mm-hmm. I'll also be posting the videos for these as well. Okay. This is our first part of the review. A lot of this stuff that I want to tell you guys to remember is important that you're able to do on these. So looking at the first one here, we got to be able to evaluate our function. What am I going to do with that -7? Plug it in. So whatever's inside the parentheses, all we want to do is just plug those values into the equation itself. So this will be 3 times -7 cubed minus -7 squared plus 5. -7 cubed times 3 is what? What do we get? $1,029 minus 49 plus 5. When we simplify this out, we're going to get what? You guys blow my mind sometimes, even though some of you guys are on your cell phones. I don't know why.
Wait, but isn't it a positive 49? Oh.
1,073.
Yeah, isn't it a positive?
What? -7 times -7 is positive 49. Times the negative again makes it negative. This right here is negative.
You don't just change it.
Giving you guys a review and you guys just... You students dumbfound me. Looking at our function here, we're looking at a piecewise value here. Piecewise, what do we do?
Plug it in.
Plug it in.
Did you plug the 5 into both?
Where's the 5 exist, on the top or the bottom? The top. It's less than or equal to 5. So it has to exist in the top one. So we're going to get 6 times 5 squared plus 12. This is 6 times 25. 150 plus 12. For the ones that are sitting in different seats, I want you guys to move back to your seats tomorrow. Ladies, gentlemen. How many of you guys don't sit there? Go back when you guys tomorrow. Okay, here we go. Next pair that we're going to get here. Looking at this, we talked about looking at domain values for different types of functions. Just by identifying the type of function we have, the only two that have restricted domains in our universe right now are going to be when y is equal to 1 over x, any type of equation like that, where x is not equal to 0 would be our restricted domain, and when y would be equal to the square root of x. So x has to be greater than or equal to 0. Does it fall in those categories? Does this equation fall into those categories? So what does it have to be? X is all real numbers. Okay, if it doesn't fit in that category, you don't have to restrict the domain. Okay, here we go. I want to try to get through all these, and I wasn't able to do that with these. Now, if there was a question to remember and a question to look over, it'd be this one. You might need a separate sheet of paper on this because it's going to be a little bit long. I'm telling you right now, you're going to have a question like this on your test. So you guys got to know how to do it. Period. You got to know how to do it. So you will have this tomorrow. You will have it on Thursday. You will have it on Monday. You guys got to know how to do this. It's not complicated, but it does get long, and I'll show you why. This is a function. It gives us a function value, and it tells us to evaluate using this equation. That means we got to find both of these parts in order to determine the rest of these. So that's what I'm going to find. I'm going to find f of x, and I'm going to find f of x plus h. Once I find those, I'm going to plug those back into my equation. My first one, what is f of x? What is simply f of x? 3x squared minus x plus 5. This one has nothing to do with it. We're not changing anything. It's just asking us to have that function value. The other one might be quite different. And I'm going to use a red pen for this. It does get long and convoluted, but it's not hard to do if you understand exactly what's happening. What am I plugging into my function? The x plus h, right? It's going to be 3 times x plus h squared minus x plus h plus 5. Now, just by looking at this, we have to be able to simplify this down. It's not as good just giving it to us like that. We got to be able to expand it. Essentially, what we're doing here, if we wanted to plug into it now, if we wanted to plug into this top equation, this would be, our equation up here would be 3 times x plus h squared minus x plus h plus 5 is one equation, which we're going to subtract from f of x, which happens to be 3x squared minus x plus 5, and then we're going to divide this all by h. So if this makes sense to you, that's all we're doing. This is f of x plus h minus f of x. So all I'm doing is I'm substituting those values in. Now, it's not easy just for us to leave it like that. We got to be able to expand it and reduce down everything we can. It's not that difficult to do that. Right, Kayla? Paying attention? We're writing this down. It kills me that I'm seeing you got a lot of you guys on your cell phones, but I'm not going to tell you guys to put them away, but just don't ask me for help tomorrow. That's all I'm asking for. I'm not getting mad. You do you. Love your hat. Beautiful, but just don't ask for help. Can't ask for help if you don't want to get help. Okay. For this one right here, we want to be able to expand this out now. So we got to expand that big portion. The other parts is pretty much done. We got to expand this bigger portion. If we can't expand it, it's going to be really difficult for us to simplify out. Now, underneath here is where I'm going to show my work, so I can just plug it back into that so you guys can see that. This is going to be 3 times the quantity, x squared plus 2xh plus h squared minus x minus h plus 5. So I basically FOILed this out to get a bigger value. I got to do one more step and expand the whole thing. So this is going to be 3x squared plus 6xh plus 3h squared minus x minus h plus 5. If any of these values can be reduced down, we can reduce it. But in this case, none of them are like terms. Yes? Have to distribute that negative into the factors. Yep, have to distribute that negative. Because none of these can be reduced, this is our full equation that we're going to input here. So this equation is going to go into this equation for this. Okay? So when we're writing this whole thing out, let's write everything out. This will be, I'm going to write this one in blue now. So this would be 3x squared plus 6xh plus 3h squared minus x minus h plus 5. That is the f of h, x plus h equation. That's all one equation. The last part that I'm going to do is I got to distribute this negative to each one of these parts. Minus 3x squared plus x minus 5. all over h. We're not done with that. Now, the nice part about this is we should be able to reduce down terms because we are using a portion of both x and h. 3x squared and our negative 3x squared go away. On the back part of this, right? Looking at this f of x, we're still distributing this negative, so I know I have negative 3x squared. Okay, we should have at least 3 terms that go away. All of our signs change. Our plus x and our minus x are going to go away as well. And our plus 5 and our negative 5 are going to go away. So all these are the ones we don't need. H, there's no h we can get rid of. So the remaining terms that we have are these right here. So we're going to bring those down. 6xh plus 3h squared plus h, sorry, minus h, sorry, all over h. Can we pull out the greatest common factor? Absolutely. We can pull out an h up in front and get 6x plus 3h minus 1 all over h. What does it reduce down to?
Do we have to put the minus 1?
Yes. If we reduce down our h, our final product is going to be 6x plus 3h minus 1. So the whole thing reduces down to something very, 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 very nice. I'm telling you right now, you're going to be able to take out an h. If you do it correctly, you're going to be able to take out an h. This is very, very similar to what you're going to see on the test. Something very, very similar. So even though the problem might look very long and convoluted and different, it's really not that hard. Plug in your function values, expand them, expand and simplify, and that's all you're doing. Plug in, expand, simplify, done. Okay. If you didn't write it in this order, could you write it in different orders? It could have been 3h plus 6x minus 1. Yeah, I'm okay. As long as you have those 3 terms in there, that's fine. Yes. I'm using this equation to plug in my function values. This equation is represented by 3 times x, whatever x happens to be. So my f equation is whatever's around the parentheses. That's what I'm plugging in. That's f of x, right? Wherever x is being replaced by x plus h. That's all we're doing. Yes.
So like, you know how at the end when you took out an h, if you just leave it as h, like
it's wrong. It's wrong. You got to be able. If you just want to reduce down because you already know you're reducing down, that's fine. Okay, but if you don't reduce down the h,
if I forget like the negative 1, does that mean it's wrong?
Partial of it, yes. Okay. Yes. You could. That's exactly what I just said for here. You can reduce if you want to automatically if it makes sense to you to cross out those out. But technically, we would have to pull it out as a factor of it because sometimes it's going to give us -1. What's going to happen, what I've seen a lot of kids do, is they'll cross these out, and think of just crossing this out and just leaving this there. But if you pull this out and you understand that this is still -1, you're reducing down even better. So if you understand the concept of it and you remember that -1, then fine. But +1. Yes.
That has red and then it's blue at the top. Why is it that it's x times x squared and then you do it minus x?
Because this is the operator that we're using for it. This original equation, this f of x plus h is 3 times whatever. So this would be 3 times x squared minus x plus 5. We're using the same function value for this. This 3 matches up with this 3. The squared term matches up with the squared term here. The plus 5 and the plus 5. Wherever, pretty much whenever you see x in here is you're replacing with x plus h. If it was a b, you would replace everything with b. If it was x minus 2, you'd replace all the blank spots with x minus 2. So that's all you got to see. All you're doing, basically function notation is just substituting a value in. It's substitution whatever it tells you to. Function notation of this front part tells you that you're substituting for every value, you're going to replace it with a whatever it tells you. If this was a 2, I'll replace it with a 2. If it was a x plus 10, x plus 10, x plus 10, x plus 10. All you're doing, that's all you're doing. I think you guys think about it like way too hard. You're just substituting those values in. That's all you're doing. I'm not trying to trick you. That's all you do. Okay? Here we go. So you definitely have to remember that one. Let's look at this one. Do me a favor. I need to change this one around for you guys. Can you change this to minus? Can you change this to minus 2? Change this to minus 2. It just looks a little bit nicer. And I believe you guys have to change the bottom one to plus 3 for it. Can you guys do that? I just want it to look nicer for you guys because I'm seeing some errors. Just change it so it's the equation that I have. You definitely have to graph a piecewise function. It's going to be a quadratic with a linear line and a constant value. So you're going to have, it's a 3-space inequality or a piecewise function that you guys have to be able to graph. Looking at these, we got to be able to graph them pretty accurate. Okay, you're looking at the transformation. What's the top equation? What does this look like? What should it look like? Anything less, but what type is it? What type of equation is it? All right, so what? It's a parabola. Okay, the parabola should be very easy for us to graph it. I'm going to show you guys just tricks on how to graph it. What is our vertex? A vertex is a key, most important thing about a quadratic. 2, -4. Okay. Is it going to be a minimum? Is it going to be a maximum? What's our A value? How about this? Let's just do this. We'll just do A. A value is what? It's 1. So 1 up in front of them. Okay. Now, it's going to be a min. Now, in this case, what we're getting here, if you have those two things, it's going to be really easy for you to graph. Go to your vertex point, which is over 2, down 4. From this point, we're going to use the A in order to help us graph it. And this is what I want you guys to use as well. From our vertex point, I know that my A is 1. And if you follow the same direction, it's going to be very easy for you guys to do. And it all depends on what A is and how you graph it. From your vertex point, we're going to go 1 away from each side on every single time. Doesn't matter what equation. If it's a quadratic, you're going to go 1 away. If it goes 1 away and the A value is 1, we're going to go up 1. Over 1, up 1, right? If it was -2, I would still go left and right by 1 each. But in this case, if I go over 1, I'm going to go down 2. Over 1, down 2. What if that function value was a half? I would still go 1 left and 1 right by 1, but I would go down by a half. Whatever the function value is going to be given you, just go by down or up by that value. So if it was 3, I would go over 1 and do what? Up 3 on each side. If it was negative 3 halves, where do I go? Over 1, down 1.5. Right? So whatever the function value for that is, I'm only looking for 3 points. Those are the only 3 points I'm looking for. In this case, our function value for this is A. Yes? The A value. The function for the A value would be the one I'm going to look at. This is the only thing I want you guys to just graph the basic idea of what the function should look like. So for this case, our A value is going to go over 1, up 1 from the notation itself. Now I'm going to graph this a little bit better just so you guys can see it. If I'm going to go over 2, okay, over 2, what's 2 squared? 4. So if you go over 2, we're going to go up 4 to this. That function value still works. Now, instead of just it being regular, right, we have 4 for this one because our A is different. We'd have to multiply that 4 by whatever the function value gives us. Right? So if A was, let's say, a half, okay, if I go over 2, we usually go up 4, but what's half of 4? You can. It's an easier way to think about it. Don't worry about that. I only care about these points, but I'm just graphing it nicer for you. Yes.
So. Anyway.
You okay? Okay. Yes.
Wait, why is there why are the points over on the, why are there points in the x-axis?
I went over. I'm plugging it in nicer. I'm just plugging it in nicer. If you plug it into your function notation, if you go 2 over, your x input is 2. 2 squared is 4, so you're gonna go up 4. But don't worry about that. Don't even worry about that. I would worry about graphing, yes, but only the first 2 points. Only the first 3 points. Your vertex and the 2 points. That's the ones I'm looking for. Okay. That's the only ones you'll need for the test. Yeah. For the next one I'm going to go ahead and graph my bottom one. This is our slope-intercept form. This is 1/2 is my slope. Yes.
Why didn't you put like the dotted line?
I'm gonna do that next. I'm gonna do that next. I'm gonna go up 3, up 1 over 2. This function is gonna look like this, going through everything. Graph my line. Now, no matter what you do with this, if you can just do that, that's half your battle. Okay? Everything else is pretty much simple. We got to be able to look at what domain values it takes on. Now, the notation for this is we're looking at things that are less than 3 and greater than 3. So I'm going to go to 3 here. I'm going to plot my line here because that's going to separate each side. This is function values that are less than or equal to -3. And the top side of this is anything greater than 3. For anything less than -3, what colored graph does it take on? What are we looking at? Anything less than 3 is going to take on what? The quadratic, or is it going to take on the line? It's going to take on the quadratic, so it's going to take on everything that's in black. So get rid of everything else that's not black from the left-hand side of the line. We got to be able to get rid of both of them because one of them doesn't exist. Where does everything less than -3 tell us it's going to be? Less than 3, but what function is it going to take on? Is it going to be the quadratic? Is it going to be the black one or blue one? Black one. So,
Like, do I have to write that down?
no, I'll just usually visually see it. In this case, because I know it's a quadratic, what equation should I get rid of? The blue. So I'm going to get rid of everything that's on this left-hand side of the blue line. Because it does not take on this on. If I were to cover this up, the only thing that it takes on should take on is everything that's in black. It does not take on the blue equation, so I got to get rid of that. Because it has to be strictly less than -3 or less than 3. Yeah, you erase it. You erase it. You got to erase it. Yeah, erase it. What about the other side? What do we need to get rid of for this other side? Now, if anything greater than 3, which of the lines take on, the blue or black? The blue. So we're going to get rid of this black equation right here. So I'm going to get rid of just that. Just the black one on this side. Okay. This takes on the quadratic, which is on the top. Anything greater takes on the line. We're done. The only thing we got to be able to consider now is, do we include 3 for the quadratic? Do we include it? Is it closed or open? Closed. So wherever it meets, closed line here. What about our blue one? Is it open or closed? Done.
Does it have to be on a specific point?
It should be, as long as you're close to it, it's fine. As long as you're close to it. This one should be a good point, right? We went 1 over, 1 up. It crosses at a good value there. So that one's fine. The other one, it kind of goes through a wonky middle one. That's fine.
So I have to make something like that.
Yeah. That's fine. Is that making more sense? Okay. If you graph both lines and you just see what the last one has to take on, well, then color that one in. Right, yes.
So if they're both included, then you would just leave like the left-hand side. Or
You're saying if it was both less than 3, if it just takes on the function value? Yeah, we would just draw this whole thing in. Yeah. We could still restrict it, but it wouldn't be a function anymore. Right? It wouldn't be a function because vertical line test. I can give you something like that. I'm not giving to you. It will be separate graphs. I'm telling you right now it's going to be separate graphs. So you just want 3 ones. 1 quadratic, 1 linear line, 1 value. So it's like horizontal line. Maybe 3 values. Okay. I'll probably do another set of these as well. So on the homework. Okay. Okay. So just reviewing on that. Here we go. Let's look at our next set. I'm going to kind of jump around with these just because I want to get to more problems with you guys. We have 34 right now. No. That'll be a review. Do you want to do it for homework? It's up to you. Am I going to grade this tomorrow? No. I just want to jump in tomorrow and give you guys time to do your team test. So when you guys come in, you guys are going to get into your groups and get started. Yeah. This will be posted today. The answer will be posted today with this material. So looking at this stuff here, I'll do them all. So we want to be able to look at evaluating these different types of functions. Being able to graph these are also crucial and important. You will have some problems like the composition of these as well. Okay, what we're going to do for the first one is we're going to look at what the function values give us. In this case, my blue one will be f. The red one will be green. Or red. The G one will be red. Sorry, the green will be, that makes no sense. The red one will be green. This tells me the first thing I'm going to do here is f of -4. So the function value on the outside of it's telling us so it's going to be f of -4 plus what? G of -4. This is probably the easiest way for you guys to see it and evaluate the function. What I'm going to do here is I'm going to evaluate them at f of -4, so it's going to be plugging these in. -4 squared minus 16 plus my g function, which is -4 minus 4. So all we're doing is we're plugging in our function and evaluating. This will be 16 minus 16 plus -4 minus 4. These are going to go away, giving me just -8. Looking at our function value for the bottom one, this is now going to be f of -5 on the top divided by g of -5. So we're just inputting these function values in. This is still going to be -5 squared minus 16 all over -5 minus 4. Simplifying this out, we're going to get 25 minus 16 over -5 minus 4. This will be 9 minus -9, or just -1. Evaluating the functions, evaluating the functions. Sorry? F of g is not multiplication. We're looking at composition this time. The small circle represents g of f, f of g. Okay, so we're looking at both of these different versions. So if I wanted to rewrite this, it would be f of g of x. There's no input value for this, so we leave it the same. What is my g function? X minus 4. So we're going to plug in x minus 4 into whatever f is. In this case, f is going to be equal to something squared minus what? So whatever's inside of that's what we got to plug in. So we're going to plug in that x minus 4 into here. So that's all we're going to try to do and evaluate. Should we be able to expand and reduce this down? Yeah, I believe you guys can do this. If we FOIL this out, and I'm going to FOIL this kind of fast for you guys. FOIL this gives me x squared minus 8x plus 16. I'm going to tack on this minus 16 here. Our final solution will just be x squared minus 8x. You do not need to factor it. We're not factoring. It doesn't tell us to simplify. Okay, it doesn't simplify, but you don't need to factor it. We don't need to factor it any further than this. I factored it. It's a composition. This is the f function. This is f of x. And we're going to use f of x up here. You're worrying me. You got it? Look at the next one. See how we do the next one. Because we're going to have g on the outside of this one this time. G of f of x is our next one. G of f of x. What is our g function? Or sorry, f function? X squared minus 2. So that's what we're going to have to plug in. So we're going to plug in the f function, which is x squared minus 16, into the g function. What's my g function? X minus 4. So it's going to be something minus 4. So that's what we're plugging into. We're going to plug in the x squared minus 16 into that. Does that kind of make more sense? Kind of helps you see it from the other perspective. So what I'm going to do here, reduce, right? X squared minus 20. That's it. Can't reduce down, can't factor. I don't want you to factor. Just expand it and simplify. You don't need to factor this out. It's not the difference of squares for this one. We can't do that. We could, but we're not going to show you guys. You guys think about this way too hard. I swear. You guys think about this way too hard. I'm not here to trick you guys. I'm just here to teach you guys steps. That's all I'm trying to do. It's like integrated 2 and 3 together with a lot more steps. That's all I think it is. Okay. The 11 we're going to evaluate, but the funny thing about, what do we know that g of f of g is? Do we know what f of g is? X squared minus 8x. What should I plug into that equation? We're just going to plug negative 2 into both of these parts, and that's all we're going to do. So negative 2 squared minus 8 times a negative 2. 4 times 4 plus 16 is going to be 20. So we're just evaluating the function. You can do the long one, yeah. This goes back to looking at the composition of functions as well. Whatever way works for you, whatever way, if you want to expand it and then do it, yeah, it's a lot more steps. Another way you can look at it is f of g of negative 2. So you can evaluate g of negative 2 first. So if we did that, g of negative 2 in here would have been negative 2 minus 4 would have been negative 6. So I want to plug negative 6 into my f function. Negative 6 into my f function would have been 36 minus 16 is 20. So you can definitely do that. So it's another way of doing it. Okay. Good? Here we go. Now, with this one that we're going to look at, we're going to hold off on number 11. This one is important, because it involves two variables. So now we're looking at finding inverses. So we're kind of jumping around because I want to cover as much as I can with you guys. This might be the last one we're doing, so everything else I'll be showing you guys on a video if you choose to do it. If you want to practice it and do it first and then check the video later, definitely do it. Be on the YouTube channel, Aguilar72. Test 3 review, part 1, part 2. Part 1 is the one I'm doing in class. You're going to hear me speak right now because I'm recording you guys. This is all I do. I record it and then I post it. So whatever you get here in class is what you guys get online. Okay, the other part, you'll see a little video of me on the right side, part 2, with the remaining equations. So my suggestion is, if you want to get better, if you want to check out to see if you did the work correct, is to try them out before you even look at the video. Just try them out. I'm not grading you on this, so just try them out. If you really don't understand it, circle them and come back to them later. Check to see if you did it right. Okay, and then follow me along on them. Pause it, rewind it if you need to go back. Okay, did I cover everything on here? Not everything. Okay, but they are going to be crucial. Okay, so just take that time. I'm going to do it during 5th period or 6th period, so it will be posted by the time I leave for school. Okay, by the time it hits like 2:20, it should be done. Okay, so for this one right here, I'm going to kind of expand this one out because it's not hard, but it is a little bit longer. So we're going to get y is equal to x plus 2 over 3x minus 4. To find the inverse, what's the first thing I got to do? Swap the x and y. X is equal to y plus 2 over 3x, or 3y, sorry, minus 4. Now, what makes this problem difficult, unlike the other inverses, is you have two y's you got to solve out for. How do we get two y's to be 1? Not yet, not yet. First thing that I would do is multiply both sides by 3y minus 4 to get rid of that fraction. Fractions confuse you guys the most. It confuses me the same. So it's going to be 3y minus 4 times x is equal to y plus 2. So multiplying both sides by that 3y. From here, what I want to do is I'm going to go and FOIL out the left-hand side. So it's going to be, or factor out the left-hand side, or distribute. So there'll be 3xy minus 4x is equal to 4 plus 2. Now, you're looking like, this is complicated, Mr. Aguilar. This is complicated. We're trying to get the y's by themselves. So we're going to pull x to the other side. So we're going to bring all the y's to one side. We're going to pull all the x's to one side. So 3x minus y. So we're going to minus y to this side. So I'm going to subtract out y. I'm going to add 4x to both of the sides. So it should be this. Now, the best thing, I have everything together. What's the greatest common factor on the left side? No. Y. So I'm getting that y by itself again. Now, what do I do to get y by itself? Divide it. Done. I will be. That's your inverse for this function. It's a really interesting one, okay? Depends. Yeah, I want to try to leave by like 2:40. Okay. This ends part 1. This ends part 1. I'll be doing the rest of them. So we'll be looking at finding max or min on these. So check on that. We'll be looking at, if I can get it.
Wait, how do you do that when it gets to the top?
We'll cover it. We'll cover it. We'll be covering max and min. We'll be covering the word problems. We'll look over.
The backside is review 2 right now.
Backside is review 2. Yeah. What's up, chat? Let me talk. This is going to be finishing up the word problem. So this is your negative b over 2a plus 12x minus. Bye, chat. Bye, guys. We'll see you guys. This will be looking at maximum intervals, domain and range, functions continuous, not continuous, and one-to-one. It will also show us min and max values for these, which is, I don't know why it's not showing us here. Sorry about this. I'm just messing up here. Bye, guys. We'll see you guys. We'll see you guys. Let me see what it gives